Philosophy of modeling. There are two ways of thinking about models. We can think about models as archetypes, or we can think about them as instances or particulars, objects, individual objects. Let's go ahead and begin with the first case, archetype. Have you ever been into a model house where it says model on the outside lawn on a sign? Well, most likely you have. The idea behind a model house is that you can walk into one and get an idea of how your house might look if you buy a house based on that model. Now, you may buy something that's different, but the model is an archetype. It's a kind of template from which your particular house would be constructed. So you could alter, for instance, the size of your rooms, the positions of appliances, where refrigerators would be located, in sinks, other plumbing fixtures. You can also choose the style of tile that you might want on the floor, and where you might want wood versus linoleum versus ceramic tile. You might change the color of different things in the house. So the model of the house is then an archetype or a template. And if you could imagine a really large machine, you could imagine feeding in the archetype into the machine, the model house, and out would come your house. Now, no such machines exist because it would be unwieldy and not very economic to create such a thing. But anyway, in your imagination, you could imagine feeding in the model house into the machine, and then out pops your actual house with all the colors that you want and the tile the way you like it, and the living room and dining room and kitchen in their proper places. This is very similar to the way you make cookies. You have a cookie cutter and use a cookie cutter to stamp out individual cookies. So the archetype is very similar also to the concept of class and object-oriented thinking and programming. The archetype is the template, and then you can create instances or individual objects from that. So this type of modeling is very common in many different areas. In document production and control, such as the web standards XML, HTML, and the standard that was created before those, SGML. Mathematical foundations in terms of model theory. Model theory is based on the idea that you have this concept. A structure may be a model for something. Computer-aided design, you may have templates, and from these templates you can create particulars. In computer science, you may have grammars, frames, schemas, forms. In particular, schema is used a lot in computer science, but it's also used in areas such as the creation of stories or narratives. And these are used in the movie theater. If you go to the cinema or the movie theater, you might see a movie, and you might classify the movie as being part of a particular schema: love schema, revenge schema, the prince marries the princess schema, and so on and so forth. So there are numerous schemas, but the idea of the schema is the same as the archetype. It's this general frame or structure that has a lot of different instances, or in the movie case, a lot of different movies follow exactly the same structure. Okay, now we also have particular. This is a different way of looking at model. We've just overviewed the idea of model as archetype or template or schema. When we talk about model in terms of instances or particulars, what we're really trying to do is use one object to represent something else. For instance, have you ever seen one thing that reminded you of another thing? You probably do this all the time without necessarily thinking about it. But for instance, if you have a baseball in your hand, that may remind you of the moon. it has the same shape as the moon, at least in a broad sense. If you throw the baseball somewhere, this might be related perhaps to the moon's motion. So this way of thinking about saying, here, I've got a baseball, and I look up at the moon, and they have basically the same shape, we may be able to use the world of the baseball in better understanding the world of the moon and how the moon behaves. And this reminds us a little bit of the Isaac Newton discovery of gravity, which you've probably all heard of, where there's an analogy between an apple that dropped on his head and the moon, or for that matter, a planet. Another good example is Bohr's model of the atom and its nucleus. Bohr made an analogy between the solar system and the atomic realm. And that analogy has helped scientists to better understand the way that atoms and operate and electrons operate and so forth. Now, sometimes analogy and metaphor can come under criticism and attack because there are extraneous artifacts or baggage associated with these types of models. For example, we now know that atoms do not have curvilinear paths. So does this invalidate the use of Bohr's model? Well, it really doesn't, because our needs as humans requires the use of analogy and metaphor as a way to understand the world. We use the physical models as ways, perhaps incomplete ways, of understanding nature. No model is exact. Instead, it represents a looking glass, kind of rendering a perspective of a thing. Let's go ahead and take a look at what modeling is. We know we have two ways of models, and ways of thinking about models. Is modeling a cognitive activity? Certainly is. Is it mainly in your head, however, or is it in the materials that you use to create the analogies and metaphors? Whether you do that on paper, or whether you do that with clay, or whether you do it with wood or plastic or any other material. Do you place more importance on one than the other? That is, do you place more importance on the cognitive activity or on the materials that you use to create the model? Is modeling an art form where one creates it for enjoyment and aesthetics? Or is it a language? It certainly seems to be a form of language. Modeling is a language in the sense that it's used within a social framework where we communicate from one person to another, or from one generation to the next by creating archives of models. Let's go to the idea about modeling as a cognitive activity. And with that, we're going to look at Plato's cave, which you may have heard about, but which nonetheless is important to the idea of modeling. So let's talk about that for a second. Plato's cave. Plato created a mental experiment where there's something interesting going on inside a cave. They're cave dwellers who are restrained somehow in that they must face a wall in the cave. Behind the dwellers, there are puppets, and behind the puppets, there's a fire. And so if we imagine this, dwellers facing the wall, puppets behind the dwellers so that the dwellers can't see the puppets, and then a fire behind the puppets, the fire projects shadows from the puppets onto the wall so that the cave dwellers can see the shadows, but they can't see the puppets, or they can't see the fire for that matter, because they are restrained in some way. Perhaps they're facing it and they have their hands tied behind them or something like that. So Plato's point with all of this is that we are the cave dwellers, and that enlightenment comes from a series of steps where we gradually realize true forms of nature. We first turn around to see the puppets, and then the fire, and then we gradually evolve to emerge from the cave. At least that is Plato's ideal, that we would evolve in such a way as to gradually realize the true forms of nature by performing these actions. And ultimately we would come outside of the cave and be enthralled to see the sun, which represents a kind of a ultimate eternal truth. Now, while all of this discussion of Plato's cave may seem quaint, you may be wondering, what does this have to do with modeling? Well, it has to do a lot with modeling, as we'll find out. It has to do with the importance that individuals, yourself for instance, place on thought versus materials used in creating models. Some people, often of a mathematical lineage, will place more importance on pure thought and less on material, as if to some extent the material is tainted or inferior. In Plato's writings, knowledge from the senses was seen as somewhat inferior to mathematical knowledge, which in turn was a little bit inferior to the idea of true form. So true form and the ultimate ideas of mathematical knowledge would be judged to be non-sensory and a manifestation of your cognition. Now, Plato's argument has been debated for 2,500 years, and it's likely to be debated for another 2,500. Certainly, Plato's roots are strong in mathematical education and mathematical modeling. People often refer to Platonic thinking as somewhat dry or devoid of sensory cues. Now, Plato generated a theory of forms, and with forms not being really unlike the archetypes we previously discussed, the forms were purely mental or actually outside of our own cognition. But to some extent, they're not unlike the model house or the Bohr model of the atom, if we think of them like that. There's also an idea of, say, mathematics of transcendental, that is, it exists outside of humanity. It exists outside of the individual. However, that idea or that concept has come under attack, especially quite recently. There are those who would state on one hand that mathematics is out there. It's apart. It's separate from humans. And to some extent this is equivalent to belief, something that is very common to the religions of the world. However, others, on the other hand, state that mathematics is a product of organic flesh and bone. It is part of us. We created it. It is a result of who we are. So Plato's hierarchy of knowledge starts from forms, which are outside of us, progresses to mathematical knowledge, which he sees as a higher form of knowledge than media, which he didn't use the word media, but we might refer to the arts, for instance, or anything that's not based on mathematical thought as being kind of a third realm of activity. All right, now, instead of looking at modeling as a cognitive activity, now let's turn the tables and look at it as, is it a material activity? Despite Plato's yearning for forms, our treatment of modeling in today's science and engineering is generally regarded as a material activity, in that we use material forms, graphical or text, in order to realize certain types of model structures. So there are hundreds of different text-based and graphics-based methods for modeling. Modeling then, especially in a material sense, is a type of language. There are elements of the language. There are words, if you will. There are icons that must be used in order to communicate from one person or one generation to the next. Now there's a hypothesis which is called the Sapir-Whorf hypothesis, which basically says ultimately that language affects the way you think. And I'll just read the Sapir-Whorf hypothesis. Human beings do not live in the objective world alone, nor alone in the world of social activity as ordinarily understood, but are very much at the mercy of the particular language which has become the medium of expression for their society. Now, some people would find this highly objectionable. In fact, many linguists do find this somewhat objectionable. The Sapir-Whorf hypothesis was issued in the 1920s, so it's fairly old. They have a point. While Sapir and Whorf make an excellent argument for the case, our language is certainly also reflective of our thought. And so the arguments then are where to place the emphasis. To what degrees does thought affect language and language affect thought? Some of what you believe may stem from how you feel about Plato and some of the discussions that we just had a moment ago. Something that fits very well with the Sapir-Whorf hypothesis is thinking about modeling as a medium. Is modeling a medium? And here we're taken to the work of Marshall McLuhan, who's a media theorist, who uttered the famous expression, "the medium is the message." Now, McLuhan gives us this phrase, and his point was that new media, printing, mechanical, electrical, computer, as we basically move through the centuries and achieve different technologies for representing media and creating media, we end up with a situation where media affects our language and the way we see the world. So that was one of McLuhan's major points. It is a view very similar to the Sapir-Whorf hypothesis, that the media that you use affect your thought and understanding of a thing. Okay, let's move on to the summary slide. We've covered a variety of issues in this talk so far on philosophy of modeling. Is modeling cognitive or material or both? And where do you place the importance? Do you place it more on the cognitive side? Do you place it on the material side? Are you somewhere in the middle? Are visualizations equivalent to or less important for modeling, in your opinion? Is the mathematics that you create in your head? Is it in the chalk on the blackboard? Now, if you say it's in your head, then to some extent everything is in your head, since we're creatures of our own brains and cognition. So mathematics is really not special in that sense, because everything we think of, mathematics or not, is in our head. However, this does not lessen the importance of the senses or of aesthetics, a term which originated from the Greek word aesthetikos, which literally means senses. Another issue is, should everything look and sound the same for all of us to communicate? Or are you concerned that we might enter a situation where we have a Tower of Babel, where ultimately nobody can understand what the other is saying? Or is it possible that we can personalize and customize model structures? What are the problems with each approach? Standardization on one hand can stifle innovation and become boring, but it achieves progress through community. On the other hand, the standard can be placed below the human interface to where people are able to communicate, but with the added benefit of personalized cultural interfaces. Models used in science engineering are very culturally positioned. Each culture, each discipline within science and engineering has its own view of phenomena. Different pictures, different sorts of mathematical symbols. Is this bad? Should everyone adopt the same sensory cues? Rules dominate science and engineering and mathematics, regardless of what material you use, or whether you don't find material use to be as important as the cognitive elements of your understanding of what modeling is. It's still the case that the rules must be there, because without the rules, we can't play the game of science. Without the rules, we end up in the domain of puzzles and pure experience. So with all of this, Plato certainly had a point. We do use our brains to think and to reason and to make language possible. Our brains and the idea of thinking is certainly something that differentiates us from many other animals and other species. So it's certainly an incredible aspect of who and what we are. But we're also more than our brains. We're not just brains soaked in fluid peeking out from a glass jar. We have arms, legs, we can see, hear, and feel. So to denigrate one modality over the others is wasteful, as we are meant to model with all of our capacities.